This video will show how to build a high-volume manual vacuum pump. This sort of pump can be used to pull the air out of a sealed environment, which is useful for many scientific experiments and practical purposes. Pulling the air out of marshmallows is a common demonstration of vacuum pressure. They first expand as air escapes from inside of them, then when once again exposed to normal pressure, the marshmallows will collapse in on themselves because the air bubbles within have been emptied. This pump is the same design that I used in my previous video to draw the air out of a PVC pipe to create this vacuum cannon. The wax vapor from an extinguished candle will cause water in the air to condense into a thick fog as vacuum is pulled with the pump. A light bulb without the glass will even stay lit for several seconds in a vacuum before burning out. This vacuum pump is composed of PVC pipe and fittings and two simple one-way valves that will be made using sheet rubber. Both valves will be mounted to a 2-inch PVC end cap, which will be modified first by drilling a hole to accept the threads on a 1/4-inch hose adapter. The hole drilled should be just small enough that the brass threads bite into the PVC for an airtight seal. The first of the two one-way valves will be mounted over this brass fitting on the inside of the end cap. Two pieces of 1/10 of an inch thick sheet rubber are given a hole in the center to fit over any of the threads on the fitting that might be coming through the cap. They are then superglued together to make up the base of the valve. A solid piece of sheet rubber of the same size is superglued over the top of the base, but only held on by glue on one side of the hole. This will allow the top sheet to flex open and let air pass by if it comes through the brass fitting, but prevent air from returning if the flow changes direction. With a ring of superglue around the hose fitting, the one-way valve can be glued permanently into place. Before making the second valve, the end cap will need to be affixed to the main body of the pump, which is a 16-inch length of 2-inch diameter PVC pipe. Some PVC primer and cement is used to join the cap to one end of the pipe. Now about a 1/4 inch away from the bottom of the cap, a hole is drilled on the side as an air release for the second valve. 5/16 of an inch is an adequate diameter for this hole. Using more superglue, another piece of rubber with a matching hole is lined up and glued over the air release. To turn this into another one-way valve, another solid sheet of rubber is glued over top, held on by only one side of the hole to allow flex. I found that for the top sheet on this valve, thinner 1/16 inch sheet rubber works best, but the same rubber as before will do if thinner sheet is not available. With both valves now in place, if a piston seals this pipe and is pushed forward, air will escape through the side, and when pulled back, the side valve will seal and the inside valve will allow air to be pulled through the fitting. Repeating this process will draw a vacuum in whatever chamber the fitting is attached to. To make the piston, I start with an 1.25 inch PVC end cap, which is already a close fit inside of the 2-inch PVC pipe, but to make it an airtight seal, the cap will need an O-ring installed. There are a number of ways to cut a groove for an O-ring, but the method I've found that requires the fewest tools is to mount the cap to a drill and use a rat tail file to grind a ring as the drill spins. The O-ring I am using is quite thick, so it takes a good deal of time to grind a groove deep enough for it to sit in. A narrower ring could possibly be used and would require less time, but thin rings are less durable and may need to be replaced more frequently. Once the O-ring has been snapped into the groove, the piston is complete, and it can be mounted to the pump shaft, which is a 20-inch length of 1.25 inch PVC pipe. More primer and cement will get the job done nicely. Before moving on to the next step, a length of 1/4 inch vacuum hose should be pressed onto the brass fitting at the base of the pump. All the moving parts that allow this pump to function have now been completed. The rest of the design is simply there to make it convenient to operate, starting with the base. The first piece used is a 2-inch to 3-inch adapter, which will need to be slid all the way down over the 2-inch body of the pump. The adapter has a ridge built into the inside wall to prevent it from being slid freely all the way over a pipe, so that ridge will need to be ground out. A large drill bit works nicely to quickly remove the problem, as can be seen here, but a razor blade or a Dremel will work as well. Some sandpaper smooths out any rough edges, and this part is complete. The second part to the base of this pump is a 3x4-inch PVC closet flange, which come with a stop in the center that is made to be knocked out from the larger end. This flange will be connected to the 2x3-inch adapter that I just modified using a short length of 3-inch PVC pipe. Because the base of this pump will be over the top of the exterior one-way valve, the joining section of 3-inch pipe will need to have a gap cut out of the